and they don't stay by themselves. More than likely, when they meet someone else, and they will have an interaction. A chemical reaction happens. Now, when the chemical reaction happens, there's a transfer of electron from one species to another. When you transfer electron from one species to another, you're talking about the formation of ion, positively charged or negatively charged. So we need you to be able to make predictions about the charges on a particular type of ion of an element there. Now, we use the term monatomic ion, meaning there is only one type of elements involved in that ion. So like the hydrogen ion, the chloride ion, and so on and so forth. We also want you to be able to predict and being able to write out the formula for a ionic compound and formed from a metal and non-metal. Well, the formula for the compound must represent no net charge, just like the atomic symbol. When you write down the atomic symbol C, carbon, H, hydrogen, there is no net charge on those atoms there. When you have H2O, when you have NaCl, the formula for the compound there, that formula also needs to represent no net charge. So you have to be able to determine the charges on different ions. And when you put those different ions together, say if one bears 2 positive charge, the other bears 3 negative charge, when you put them together, there is one net negative charge. Well, you have to write out the correct formula. Multiply the one with the 2 positive charge by 3, one with 3 negative charge by 2. You put them together, write the formula. There is no net charge. Total of 6 positive charge versus 6 negative charge there. So we want you to be able to write out the formula now of the ionic compound there, and also be able to produce a formula for an ionic compound that contains what we call a polyatomic ion. Now, polyatomic ion is in contrast with the monatomic ion. Poly and mono, poly means more than one type of elements involved in there. Okay. So basically, we're asking you to be able to write out the formula. I always use this analogy there, and like studying chemistry is like learning a language. The alphabet is given to you in the periodic table. Okay, now that we know the alphabet, we may not memorize all of them yet, but we know what they are, where they are in the periodic table. Now, if different compounds, different atoms react with one another, if they form a particular compound, you are going to be able to put them together. This is like using the alphabet and spell out words. Once you're able to spell out words, you can put words together. You can write out sentences. And when you can write out sentences there, you understand what's going on in the language of chemistry. So this is the objective here. Now, the learning objective in chapter 2, and for this particular learning objective in chapter 2, learning objective number 3 there. On page 8 of the chapter 2 learning objective, there is a table there with 16 polyatomic ions. I need you to memorize all of those 16 polyatomic ions. Their name, their formula, their charges. And I will tell you, you will be tested on that information in the upcoming exam. So look at that table there. Make sure I have that table on the PowerPoints there. It's on page 8 of the chapter 2 learning objective. Okay. Make sure you memorize them. Now there are many, many different types of polyatomic ions there. We only focus on those 16 commonly used, commonly seen polyatomic ions there. And if you look at your textbook actually has a table with probably 30, 50 different polyatomic ions in there. We don't need you to memorize all of them. I'll try to make it easy for you. Only 16 of them. And on page 8 of the chapter 2 learning objective there. So we saw this in the previous section there, the formation of cations and anions there. Now that's for each individual element, atoms of each individual elements. Now, when we form an ionic compound, what happens in terms of the electron transfer? Using sodium and chlorine as an example there, we know sodium number 11, so we have 11 positive charge, 11 negative charge. And in the course of the reaction there, sodium tends to give out electron. Okay, so after losing the electron there, sodium becomes positively charged. Okay, and then you end up with sodium cation, Na+. And the chlorine, on the other hand, will pick up that electron. Now, here's the thing. energy is conserved, so is matter. Electron is a matter. Now, in order for someone to throw out an electron, there has to be someone else out there willing to take it in. You can't just say, in sodium, you can't just say, I don't like this electron, I'll throw it now. There has to be someone out there to take it in. So in this case, when sodium and chlorine react with one another, the sodium says, I don't like this electron, I want to give it out. And chlorine says, okay, you don't want it, I'll take it in. So the electron goes from the sodium to chlorine, and the chlorine will have, after acquiring that electron there, 17 positive charge, 18 negative charge, you end up with a chloride ion. The result of this is the formation of sodium chloride, an ionic compound. Okay. Now, the ionic compound, we don't use the term molecule to describe ionic compound, simply because there is no single unit of NaCl in sodium chloride crystal. The ratio between sodium ion, chloride ion is 1:1. If you dissolve sodium chloride in water, you end up with free ions of sodium, Na+, and free ions of chloride, Cl-. Okay? So there is no molecule of sodium chloride per se. How is that different compared to sugar? Now, if you have sugar, glucose, the molecule of glucose, carbon 6, hydrogen 12, oxygen 6, that molecule is water soluble. If you dissolve that molecule, if you dissolve that compound in water, you actually have a molecule of glucose there. 6 carbon, 12 hydrogen, 6 oxygen, they stay together as a unit. So that's what we call a molecular compound. For ionic compound, however, there's no such thing as a building unit of the compound there. This formula only represents the simplest whole number ratio between the element of sodium and the element of chlorine. It's a 1:1 ratio in this case. Okay, so that's the formation of the sodium chloride compound, ionic compound there. And then we have different types of chemical bond. Now, I have issues pronouncing the word bond. I always say it like bond, B-O-U-N-D. So you have to bear with me. That's my second language. Keep thinking about James Bond, but I just can't say that word. So one student actually last semester said, well, you keep saying the word bond, and I started writing down B-O-U-N-D instead of B-O-N-D there. Different types of chemical bond, ionic bond, okay? Now, ionic bond is the result of attraction between the ions of opposite charges, positive, negative. Okay? The formula unit represents the simplest ratio of cations and anions there. So for NaCl, for sodium chloride, it happens to be 1:1. For calcium chloride, it's 2:1, 1:2, or in that case, CaCl2. Okay. Aluminum chloride, AlCl3, 1:3. Okay. So we don't use the term molecule to describe ionic compound. Rather, we use a formula unit. The formula unit represents the simplest whole number ratio between the cations and anions there. Remember, the formula must represent no net charge. Okay? So if you look at NaCl, we know there's a positive charge here, negative charge here. No net charge. The formula of calcium chloride, 2 positive charge, 2 times 1 negative charge, no net charge. Okay? And aluminum chloride,